Part 2, I'm going to explain for the full wave rectification. So later, our circuit will be constructed just like in this electrical figure, where we are using the same signal source from our previous half wave rectification, and then it will be connected to 4 diodes in parallel, in 2 sets of parallel, and finally connected to our loads, which is again we are using 1 kilo ohms of load. And then for the input signal, as you can see in figure 1, it will showing an AC waveform where we got the negative cycle producing the negative V minimum, and for the positive cycle it's producing V maximums of positive value. But we do find out for the output signal later, it's producing totally different kind of waveform even if we compare to the half wave rectification. Here, as you can see in figure 2, the waveform on the positive and negative cycle are actually producing positive waveform with value of V maximum positive. And let's seek the truth of this knowledge through the simulation. So here I already make the simulation, construct the circuit as same as the previous slide, but here I add an additional of oscilloscope, where for the A probe we connected to showing and indicating the waveform produced from our signal input, and then for the B part we connected to the resistance, to the load, where we're going to show the waveform produced after the rectification process. So let's run the simulation and then open the oscilloscope. This is the waveform produced. Just set to single and then reverse so that you can see the waveform clearly, and then zoom in. So here, this is the waveform that produced. As you can see here, the red waveform actually showing the signal from our input, and then the blue one is the waveform produced after the full wave rectification. As you can see here, on the negative cycle, actually our rectificated waveform turns to producing a signal as same value and size and shape as the voltage or waveform produced from the positive cycle, and it's keep repeating again and again. And another observation that we can see throughout the simulation is that V maximum on our output slightly less comparing to the V maximum from our input that we insert. So how this happen, we're going to explain later. But one thing I want to tell is that if we want to calculate all the value of V max, V minimum, the frequency and so on for our voltage, for the output signal of our full wave rectification, we can add another oscilloscope, or we can use another oscilloscope, connected the ground to the ground of our circuit, or right here, same ground, and then use the channel 2 or channel 1 connected to the input or to the positive terminal of our output signal, and then we turn our oscilloscope, run the simulation, turn on the power, and then turn on this measured value, this measured button, and get all the value that we want. So let me skip this part, and then we go back to the simulation, to the slide presentation. Now all the value from the previous simulation have been stated inside of this table. As you can see, output from our full wave rectification slightly changing for the type of frequency, voltage, cycle RMS, maximum minimum voltage, and for the periods. And then if we comparing between the output of full wave and half wave, we do find out that the frequency of full wave and the minimum volts of full wave slightly greater compared to the half wave. But for the V peak to peak, cycle RMS, maximum, and periods of full wave are less comparing to the half wave. And here, the most important that we want to mention is that why the voltage peak to peak produced by the half wave slightly greater compared to the full wave. So again, for full wave, we're going to explain in two conditions, which the first one is for the positive cycle and the second one is the negative cycle. So let's look first for the positive cycle. So in the positive cycle, again, the voltage and current will flow in the clockwise direction, where the voltage will start on the positive terminal of the V1, then going through to the S1, which is the first diode, and then connected to the R1, which is our load, and then connected to the S2, which is our second diode, and finally go back to the negative terminal of the V1. So here you can actually clearly see that our current and voltage already go through twice or two diode, which is diode S1 and diode S2, and that's explaining why our voltage peak become less for the full wave comparing to the half wave, because it need to deduct 2 voltage drop because of 2 diode S1 and S2. And then if you want to conformize this information, we can deduct the V maximum by the input signal with the V maximum from the output signal of full wave rectification, and we got the value of 1.4 volt. And if we divide by 2, because of there is 2 diode, then we got 0.7 volt, indicating the voltage drop at every diode. So as you can see in figure 4, because of the connection are totally connected, then we can gain the value, and because of the connection is positive to negative, then we got the value of waveform in terms of positive value of y-axis. Then we go for the second cycle, which is negative cycle. Even it was negative cycle, but you need to know we are using AC, alternating current, so our terminal will be changing every time. Maybe for the first cycle it was positive on top and negative on the bottom instead of the figure, but later for the negative cycle, the positive terminal become at the bottom and the negative terminal become at the top in the picture. So our connection will start from the negative of V1. Actually it was positive terminal during this cycle, and then it's connected to the S3, which is our diode number 3, and then continue to the resistor number 1, and then continue to the S4, which is diode number 4, and finally connected to the positive terminal T1 V1, which indicates as negative terminal during this cycle. So again, here we saw that our voltage and current go throughout 2 diode, so that's why we will deduct 2 voltage drop. And finally, as you can see in figure 6, since the connection of positive to negative, then it's producing waveform in terms of positive value on the y-axis. So this explaining why during the full wave rectification, it's actually producing positive value of V max positive on both positive and negative cycle repeatedly. So I think that's all from me. Thank you.